For lesson 5's homework, we're going to start to finish up a little bit with our proofs of parallelograms and our rectangles, rhombus, and squares, and so on. So this one says, given PQRS is a rectangle and M is the midpoint of SR, we want to prove that PM is congruent to MQ. So as I look at that, I think I'm probably going to end up proving that these two triangles are congruent. But just like all of our proofs, we'll start with our pattern of going with our givens. So PQRS is a rectangle and M is the midpoint of SR. So that's going to be our givens. So I'm going to work with the midpoint part first because I think I can just use that and kind of get it out of the way. So SM is congruent to RM, and that's because a midpoint divides a segment into two congruent segments. So now I'm done with that piece, and now I'm going to move on to the fact that I've got myself a rectangle. So the first thing that pops into my head is I want to try to use that there's some right angles in a rectangle. So for step 3, I'm going to write that PS is perpendicular to SR and that QR is perpendicular to SR. And we know that because one of the properties of a rectangle is that consecutive sides in a rectangle are perpendicular. So then I can lead into my right angles where angle 1 and angle 2 are right angles. And this goes back to last unit, regular perpendicular rules. Perpendicular lines form right angles. And then in step 5, I can say that angle 1 is congruent to angle 2 because all right angles are congruent. So now I have a side and an angle in each triangle. And now what I'm going to look to do is just kind of finish off this last piece. And I'm going to use another rectangle property. And that's in step 6. I'm going to say that PS is congruent to QR. And that's because opposite sides of a rectangle are congruent. So now if I look at my two triangles, I have a side angle side pattern in both of them. So step 7 is going to be triangle PSM is congruent to triangle QRM by side angle side. And then for the last piece, for step 8, to get my proof statement, PM is congruent to MQ, and that's going to be a CPCTC problem.